So welcome, Jacob, and this is week 9. So we're coming to a close, and I thought I'd give just a little talk about what's happening from now. So first thing is you should have all gotten your midterm results. I don't know if you saw, Jacob, but hopefully you did. But everybody took the midterm, and I put feedback. I was going to do a audio feedback, and it requires Flash. And I got a note that says, I can't use Flash on this computer, so I had to do it by written. So sorry about that. I tried. I don't think that's too big a deal. The main thing with the midterm is make sure you check. I put the key online. Did you see, Jacob, the key to the midterm yet?
I actually haven't checked it yet.
Okay. It's a good study tool for the exam, for the final exam, because that's the next one of the next two big things coming up. And that is the final exam. So that's just in 3 weeks. So make sure that you start thinking about that. Make sure you schedule time to study. That's really important because it's comprehensive. So you're going to have to know from day 1 to the last day of class. So it does take a lot of, it's weird. It's asking me to admit people instead of just people joining in. So something weird happens. Hey, Josh. Thanks for coming. It's you and Jacob right now. And I was just talking about what's coming up in the class. We only have 3 weeks left. Today we're gonna be doing chapter 11, and chapter 11 is on chi-squared. And the main thing, we're gonna fill in a big gap that we have not done yet when it comes to analyzing data. We've done the yes/no survey question, and we've done the quantitative survey question. What haven't we done yet?
Combination of the two?
No, something different than either. The one that you think you may not be able to do statistics on, but you can. Qualitative, that have nothing to do with yes, no. So things like, what state were you born in? There's no yes, no on that. There's no way you can turn that into a yes, no. It's not a number. It's not 21st state. It's Alabama or something like that. So we want to be able to deal with qualitative studies. So that's going to be, chapter 11 is all about qualitative studies and some odds and ends that will happen, but that's the main thing. I want to remind you that you want to be thinking about your project soon. So I'm hoping you have lots of progress already. Some of you have posted or emailed me. Posting is better, by the way, because then people can get an idea of what other people's projects are about so they can see. So it's better to post than to email me. I'll check both, but I'd rather you post because it's being nicer to everyone else if you post, because that, again, helps the rest of the class. So post your H0 and H1, and then talk about what your population is. A lot of people have sent me either via email or posting, some ideas for their project, but they just said, and we're going to compare men and women. But the problem is that you can't compare men and women because there are 7 billion of them. And there's no way you're going to get anything even close to representative of the world. So typically you're going to be looking at people in your community, or people at your college, and it could be men or women or whatever, but definitely to do any study about everyone in the world is pretty impossible in a week. This is all you've got, a week and a half, I guess. So again, identify your population, and that's a big part of the project, is to know who your population is. The other thing is the population needs to be so large or so difficult that you can't get them all, or even most of them. Okay, so I've had actually 2 people want to look at snowpack in South Tahoe and snowpack in North Tahoe, or weather in South Tahoe and weather in North Tahoe. The problem with that is if you look at the annual snowpack, we only have records of 100 years or so. It doesn't even make sense to talk about ancient times because we have glaciers and stuff. So you can get it all. And if you can get it all, then there's no reason to do a confidence interval hypothesis test. Statistics is always about the fact that you can't get the entire population. So you must just collect some data and then see how good that data is. Make some confidence intervals or hypothesis tests based on the data. And that is really important. If you can get everyone, it's really not this class. There's no reason to do a confidence interval if you can be 100% confident about something. So that's just a note, kind of the main things I've noticed in things that didn't quite work for the project. That was one of the biggies, is the population was so small that you could just get them all. The other one is make sure that you think about what your data values will be. So if it's a survey, what somebody might ask your partner. And if the partner doesn't answer with a number, it's not an okay project, okay? Or take one measurement or one data value and see, is it a number? If it's not a number, it's not an okay project. So you must have numbers. Okay, and I'll be checking the forums, as I always do. Hopefully you figured that out by now. I'm kind of crazy about that, is that I will check usually 50 to 60 times a day. I don't know if you noticed. There's gaps because I'll be teaching or something, but I check all the time. I'm sitting there, believe it or not, I'm looking right now. So I got 2 screens in my office, and I can check and see if anyone's got anything. I won't answer now because I'm working with you guys. But there are no posts in the Q&A and discussion forum. There are 3 for the chi-squared test. This week, because there's no midterm, this is a regular week, you do have a regular discussion post. This is going to be a little harder to find an example. It needs to be peer-reviewed and use chi-squared. And if you just type chi-squared in Google, it's going to get you a statistics article and not an article that isn't statistics that uses statistics. And that's a requirement. It should be something that is about something else that uses statistics. Okay? And typically, what my recommendation is put in the words of what you're interested in terms of what a journal might have in it, and then throw chi-squared in. But don't start with chi-squared, or you'll end up with something on chi-squared, and that's not what you want. So that's the main stuff coming up between now and the rest of the quarter, is that. Okay, and you know where you stand. Please look at my comments that I put on your midterm. I talked about not just how your midterm was, but where you stand. Some of you doing great. Some of you are did well in the midterm, but you haven't done anything else in the class. And remember, there's 50% for the tests and 50% for other things. So if you do nothing of one or the other, then you didn't pass. So you have to do both. You have to do both. So that's something to note, is focus on both the week-by-week things you have to do and the midterm and the final. So are there any questions before I move on to some qualitative examples? Any questions? Okay, so let me actually, well, I'll talk and do this at the same time. So let me go and do some sharing. There was a chat. Let's see. Did we end up making videos for each person? Did I end up making? No, it was such a pain. I was bummed. I went to make the first video, and it said, can't work because Flash is not supported on Chrome. And I only have Chrome, and I'm like, oh, man. So I can't do anything about it. Sorry about that. What I did is, so I did a lot of typing. So you get the same idea, but I would have rather done the video. You've all had technical issues in your life, and that was one of them. So sorry about that. So the videos for that aren't going to happen because Canvas uses Flash. Chrome doesn't use Flash. I was on a Chrome only laptop, and sorry. Okay, but I did put in lots of notes. Okay, so now let me share my desktop. Actually, you're going to start by seeing very little, and then I'm going to pop it in. This will be interesting. Let's see what happens. Oh, good. I wasn't sure if the little jagged edges when it doesn't like a grammar thing I've got was the matter. Okay, so the question is traffic equally bad in the north, south, east, and west shore. So again, if you're not from Tahoe, most people in Tahoe know that that's kind of how we usually talk about our Tahoe area. The college, hopefully those who are in Tahoe, you better know you're in the South Shore. And we all complain about traffic all the time, okay? Which might be ubiquitous all over California. Everyone complains about traffic. But the question is it all the same? Are we just all complainers for the same amount of complaining? So a count of 600 randomly selected cars in the Tahoe Basin found 170 in the North Shore, 212 in the South Shore, 110 in the East Shore, and 108 in the West Shore. So conduct the appropriate test and provide your interpretations. Okay, so this is new. And what's new about this is a couple things. The main thing is, what is the survey question? Okay, the survey question is not, is traffic equally bad? That's the question of the study, but not the survey question. So maybe, if any of you guys know, maybe you could put in the chat box. If I can find it, let me get that chat box. Oops. Oh, there it is. What is the survey question? So what do you think the survey question is for this particular study? Are there more cars coming to and from each individual? That's the question of the study and not the survey question. A little like some of you are interested to see if, say, men do more, is there a difference between men and women in whatever you're looking at? The survey question is not, is there a difference between men and women? The survey question is what you're going to ask that individual man. Do you see that? Okay. So maybe I'll let you know, because I'm not seeing y'all jump in. The survey question is, what you're going to ask the driver, what shore are you driving in? And their answer is going to be, I'm driving in the South Shore. Do you see that? It's not a number. It's not a yes or no. The survey question here is qualitative. And when you have a qualitative study, it's very different than what we've done before. So the first thing, and this will be true of this entire chapter, is we're going to write H0 and H1. And the way I like to remember is these are for qualitative studies. So H0 and H1 are going to be qualitative, which means words and not symbols. So we can look at it that way. So we're going to have H0 is the following. That is, you think about the status quo is that it's the same for all four. Do you remember, put in the chat box, what is the word we use in statistics when it's the same for everything? There's a special word. We had a whole chapter based on it. It's not normal. That's a hint. You remember? Uniform. So you remember uniform meant it's the same no matter where you look. Okay, so in this case, H0 is the distribution of traffic in the Tahoe area is uniform. Okay, and yes, you will lose points if you don't use the language of statistics. That's a big part of this class, is to be able to use the language of statistics instead of just kind of, texting something. So you need to be professional, and this is how professionals write. Okay, so H1 is really easy once you know H0. H1 is the distribution of traffic in the Tahoe area is not uniform. Hope you agree that was easy. You just put the word not in there. Any questions, Mariel or Josh or Jacob? Any questions? So this is already should be looking very different than the other H0 and H1s we've had. I want to give you a big, giant warning. Okay, this is for qualitative studies. We're using words for H0 and H1. You're not allowed to have any words for H0 and H1 in anything we did in Chapter 9 or Chapter 10. If you do put any words from Chapter 9 or Chapter 10 in your H0 and H1, you will lose points. Okay? Similarly, for Chapter 11, there are no symbols. So you got to get that straight, or I will take off points. So there's no symbols for these H0 and H1. Any questions so far? Okay, so we're going to have to use a new distribution. I think I'll just draw a little picture just to tell you that it happens. I'll change the color on that one. So the distribution does not look normal. It does not look uniform. This is called a chi-squared distribution. And a chi-squared distribution is as follows. It looks kind of like that. Kind of like that. Okay? And you'll notice this is not normal, it's skewed. So this is a skewed to the right distribution. The other thing is it actually stops. A normal distribution goes left and right forever. A chi-square distribution never gets below 0. So maybe I'll even put a y-axis in there so you can see that was supposed to be a straight vertical line. So that's your y-axis, and it actually never gets below 0. And you might guess that because of the name. It's a chi-squared distribution. Squares are never negative. What I'm not going to do, and trust me, you don't want me to do this, is explain the mathematics behind this distribution. It's intense. But there's some normal stuff in there, and it's just rough. So we're not going to do the math because it's too hard. But I do want to let you know we now have a new distribution. So we've had a bunch of distributions in the class. We've had the uniform, since it's written up here, I figured I should mention it. We've had the normal distribution. We've had the t distribution. And now we have a chi-square distribution. And I guess we've had the binomial also. So we had 5 different distributions. And there'll be one more in our last week of class called the F. And that will happen in when we get there. So any questions so far? Any questions?
How do you spell chi?
That's a good question because it doesn't look like what it sounds. It's C-H-I.
Okay.
C-H-I. And it's a capital Greek letter. And let me draw it. So here, I'll show you 2 ways of spelling chi. One way is that. The original way is that. Kind of a curly X looking thing. And that's a Greek letter. Okay, and again, if it's chi-squared, you put a little square there, and that makes it the chi-square distribution. Any questions at all on kind of the ideas first? Okay, so now what we're going to do is we're going to go to our calculator. Now here is, let me ask you, and you need to all answer, by the way, because this is important. Jacob, Josh, and Mariel. And by the way, all of you are watching this on YouTube, you need to be getting your calculator out right now because you may not be able to do this. And if you can't, then you're going to have to struggle a little bit. And I'll talk about that a little bit. Okay, so get out your calculator. Hopefully you have it. And what I'm going to do is I'm going to show you a calculator. After I get some water, I can't talk anymore. For some reason, talking at a computer just sucks out the water. Okay, so let me reshare my screen. And let me get there just a minute. Okay, so we're going to do what's called a goodness of fit test. And that's when you want to find out whether the data fits a distribution. In this case, we want to find out whether it fits the uniform distribution. So this is going to be called the chi-squared goodness of fit test. So to do that, what we do, actually, let me unshare and reshare because I realized I want to do something on Paint first. Sorry about that. So what we need to do is I'm going to make a table. And the table is going to have 2 rows. It'll have 2 columns on the calculator, but I didn't have a lot of room for that. So O and E. On the calculator, it's going to be L1 and L2 as you're used to. And the observed, O stands for observed. And the observed were 170, 212. And then we had 110 and 108. Gotta make it wider. There we go. Okay, for the expected, what you do for the uniform distribution, you say, well, how many would you expect if it's uniform? Well, there are 600 cars, and if it was uniform, there should be just as many in each of the locations. So what would you have to do math-wise? Not too hard.
600 divided by 4.
Yeah, 600 divided by 4. Very simple. Okay, I see Mariel putting some formulas in, which you can. We're not going to need those formulas, but we can put them in just for fun. 600 over 4, which is 150. And again, if it's uniform, they should all be 150. That's what uniform means. They're all the same. Any questions on that? Okay, so now what we can do is now I'll go to my calculator. So I'm just going to clear everything out. And now I'm going to go to Stat, this you're used to. I'm going to go to Edit. I need an L1 and an L2. We haven't used L2. I guess we did the last chapter. So I'm going to erase all those. And in L1, I'm going to put the observed. So the observes are, let me go find it. It was 170. And then 212, 110, and 108. The expected were 150 each. 150, 150, 150, and 150. Any questions on that? Okay, so now this is what you really need to do. You need to cross your fingers and hope your calculator has it, because not all of them do. So you go to Stat again. We go to Tests. And it's much easier to use the up arrow, by the way, because it's almost at the bottom. And you'll see GOF. That's a little chi-squared GOF test. Jacob, Josh, and Mariel, do y'all see it?
Unfortunately, no.
Okay, so you're a bit screwed. Sorry about that. Josh, you're far away, aren't you?
Yeah, well, I live in between Mammoth and Bishop.
Okay, not close to Tahoe, though. Okay.
No.
If you're in Tahoe, you can come to my office and I can download it from my calculator to your calculator. If you're not, it's a long drive. So then I'll have to show you. I'll show you how to do it. So you don't have it either, Jacob? Bummer. Mariel, do you have it? Okay. Yeah, come to my office during office hours, and Jacob is a little easier for you, and you have it, Mariel. It's one of those weird things, and you can't even tell by looking at the calculator. If you look at this, you don't know if it's there or not. It just happens when you test. The older versions don't, the newer versions do. Okay, so just for now, follow along, and I'll tell you what's going to happen. Observed is L1. If it doesn't say L1, put L1 in there. Expected is L2. DF. DF stands for degrees of freedom. And the degrees of freedom are the number of categories minus 1. It's not the sample size, it's the number of categories. So for this study, how many different categories are there? There's 4, right? Because there was north, south, east, and west. And there were 4 of them. Minus 1 is 3. Don't worry about the color. I never understood that anyway. And hit calculate. Any questions? Okay, so it doesn't give you much. The 2 top ones are what you need. The first one, do you remember what we call this? It's chi-squared, and what do we call this thing when I asked for the what? Do you remember? What might the question be on a test or on?
The statistic?
Yeah, the test statistic. So the test statistic is chi-squared is 50.72. So if you're asked for the test statistic, that's what you put in. And then I hope you all know P at this point. That's like the whole main point of the last few weeks, right? Okay, is the p-value 5.61?
No.
Definitely not. P-value is basically 0.
Yeah.
Because we have to move the decimal 11 places to the left. So it's going to be 10 zeros and then a 5. So p-value is basically 0. And Jacob, you should have known that from the start. Okay, why did I say that?
You said it on the last webinar.
No, because Jacob lives in Tahoe. And if you don't know that the South Shore has a lot more traffic than everywhere else, then I don't know where you've been. Number of cars. The rest of you wouldn't know that necessarily. But if you live in Tahoe, you know the South Shore is the busy part. So, but, you know, given if I didn't make up these numbers, this would be a good test, and we now know it for sure. Okay, not for sure, but with very, 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 very strong evidence. Do you see that? This does not tell us the South Shore has more traffic. This tells us the traffic is not uniform. If you want, and I'm going to start saying this more often now that we're getting towards the end, if you want to do more and see, you know, which is the one that makes it not uniform, is it the South Shore that had so much, or maybe it was the West Shore that had so few? Which is the culprit of not being uniform? Any guess on what you have to do? Trick question?
Compare them all?
It's a trick question as a hint. You need to take another class in statistics after you're done with this, and take advanced statistics, because this is elementary statistics. So I want to let you know there is a lot more in statistics other than this class, but we can only do so much. Okay, there's something called a Tukey analysis. I'm not going to get into any of that stuff because that's advanced statistics. But I do want to let you know that there is more you can do. Okay, the story's not over when you find out it's not uniform. Then you want to find out, right, what is it? And that we don't know. Okay, that we can't do in this class. Okay, but we can do, and I think what you'll like is that it's going to look just like what we've been doing. And it's a little easier, in fact. So I can now state the conclusion very simply because we know how to state conclusions. Let's do it in purple. Actually, let's do it in, yeah, purple will work. So there is strong, right? If you want even better, is very strong. Statistically significant. Evidence to support the claim that the distribution. And now you just restate H1 of traffic in the Tahoe area is not uniform. And that's it. And again, this is something you should already understand because we've been doing hypothesis tests for a while, is that when we have a very small p-value, super small, you can say there's very strong statistically significant evidence to support the claim that, and then you just state H1. And that's standard. Any questions at all? Any questions at all on this particular example? Okay, so let me do another example. I'm going to erase. So speak now or forever not be able to see it. And let's do another example. Okay, so the next one. A study was done to see if there's a difference in the distribution of cars for men and women. Of the 200 men surveyed, 70 owned a foreign car, 110 owned an American car, and 20 did not own a car. Of the 300 women surveyed, 110 owned a foreign car, 158 owned an American car, and 32 did not own a car. Conduct the appropriate test and provide your interpretations. Okay, so any questions on the question? Any questions on the question? Okay, so there's no questions. What is different about this one compared to the other? There's something very different about this one. In the last one, we did a study. We wanted to find out if we had a uniform distribution.
This one's comparing owning a car and not owning a car as well.
No, not own a car. In fact, if I didn't even have the not own a car, then it wouldn't make any difference. Nothing special about the not owning a car. Something real special about this. Something very different. Okay. So maybe I should explain. In the last example, we had one population, and we wanted to find out if it fit a distribution we know about called uniform. Here, we don't know the distribution of either population. We're not trying to say it's uniform or normal or anything like that. We just want to see, we're comparing two populations to find out if they have the same distribution as each other. Whereas before, we had a known population, and then we wanted to, or known distribution, and we wanted to find out if this group had that known distribution. So this one we have two unknowns, and we want to see if they're the same. So the last one, and I'm going to write this down because I think I forgot to, I never wrote down the words. I said it, but I didn't write it down. The last one was goodness of fit. And that's what that GOF stood for. This example is test for homogeneity. Okay, test for homogeneity is a name we're going to use for this particular example. I wanted to remind you on the last one, that word distribution, we had in H0 and H1, the distribution was uniform. If you don't have the word distribution, then I will take off points. Okay, that's the statistical language. In this one, it's almost the same, except it's going to be distributions because there's two populations. So in this one, we're going to have the plural of distribution because we're looking at two different things. Okay, so for this one, let's write down H0 and H1. By the way, most people find this section not that hard. Hopefully you'll agree. So this is a good time to start working on your project because it's not that hard a section. So H naught is the distributions of car type for men and women are the same. Oops, forgot to put S. Any questions on that? Very simply stated, and you want to make sure it's simply stated. You need to have the word distributions in there. And then H naught is that they're the same. H1, I bet you can guess, is how is H1 going to be different?
Not the same.
Yeah, not the same. This is, is this feeling like it's going to be one of the easier chapters?
Mm-hmm. Except for the calculator error.
That should be 4 not of, sorry. Just grammar. It's not a statistics thing. Are not the same. That's it. Okay, so here's the good news. The good news is that any calculator, all the TI-84 calculators, and 83s, by the way, have the right buttons. Okay, goodness of fit, unfortunately, was not programmed into the 84s until somewhat recently, about 5 years ago. 83s didn't have it, but they both have this particular one, the test for homogeneity. And I'll show you how to do it. So now let's go ahead and let me, oh wait, before I do that, let's do a table again. And it's not observed and expected anymore. Now it's just men and women. Hopefully that makes sense to y'all. And we have foreign, American, and none. So foreign, American, and none. And then we have our men. I'm just going to write M and W. And for the men, what we had was, just a minute, 70. And then 110 for American. And then 20 for did not own. And for the women, we had 110, 158, and 32. Okay, and it's just a note, it's not obvious whether the distributions are the same or not from this. They're not going to be exactly the same percentages, by the way. But the question is what statistics is always about, is are they far enough away from each other that we can say we have evidence? Okay? Because if they're the same and you do a study, you're not going to get exactly the same. You're going to get close to the same because you only have samples. So that's just a note. Okay, so what I'm going to do now is I'm going to go to my calculator. And let's clear it out. And this is totally new. Okay, you've probably never used this button before, this sequence of buttons. You hit second matrix. So second matrix. Then what we're going to do is we're going to go to edit, hit enter. Okay, so notice we had 2 rows and 3 columns. So 2 is good. and 3 are the number of columns, not 4. And hit enter. And then you're going to put your numbers in, just like we had in the table. So the numbers, we had 70, and then we had 110 and 20. And then we had 110. We had 158. And we had 32. Any questions on this? This is, like I said, this is brand new probably to all of you in terms of using a calculator. We lost Mariel, but we still got Jacob and Josh. Okay, any questions so far? Okay, so once I have that in, I'm going to go to stat again. I can go to tests, you're used to that. And I'm going to go to the up arrow. And this time I'm going to go to chi-squared test. Okay, so for goodness of fit, look for GOF. For homogeneity, or the next one we're going to do later, look for just chi-squared test. And then enter, and you will have that on your calculator. So observed is A, expected is B. Okay. Don't worry about the expected, but there is a way of computing the expected. And there's a little formula, and you can see it in the book if you want. But it's not too hard. More importantly, we're going to go to calculate. And there it is. It gives us everything we need. It even has less noise than we needed before. It has chi-squared is 0.2658 about. So that's the test statistic. And the p-value is 0.875 or 876 probably. So hopefully, you know, even though you've never seen this particular test before, you should be able to look at that p-value and know what to do. Okay, that p-value is gigantic, right?
Yeah.
So what is the conclusion in general first?
Fail to reject.
Fail to reject. Okay. So again, this is like the main thing in all of this class is understanding the p-value. And understanding if you have a big p-value, it means what we got is just not that unlikely if H naught is true, so we can't say H naught is false. And that's what the p-value is all about, okay, no matter what test you're using. Okay, so next I'm going to type in, and it's very simple actually, the conclusion. And I can say there is statistically insignificant evidence. Sometimes you say insufficient. And then I like to write it this way: to make a conclusion, whether or not. That covers your bases. Whether or not. And then you state, and it doesn't matter, you can state H naught or H1. Because as soon as you say whether or not, it doesn't matter. Whether or not the distribution of car type for men and women are the same. Okay. If you said are not the same, it means exactly the same thing. I don't know whether or not it's true is the same as I don't know whether or not it's false, right? So that's why if you remember the whether or not, it's really easy. Any questions? Is this feeling not too hard?
Not too hard.
Okay. You know, it's always harder when you try it yourself, but you know. Okay, let me do another example. And this one's going to be a bit different. And it probably won't, you've never copy and paste well, because it's going to have a table in it. But I'll do my best. Let's see what it looks like. Yeah, I don't quite understand why Wednesday gets the little borders and the rest don't. I have it in Microsoft Word and it has a beautiful table. So that's not like a trick question, that's just weird paint formatting. Okay, so now what we're looking at is there a relationship between the day of the week a person is born and the type of smartphone they own? Okay, what do you think? It might be true. If you're do you even know, Josh and Jacob, what day of the week you were born in?
No.
You don't? Okay, I know no one remembers when they were born, but you might know. I was born on Tuesday. Okay, it's kind of the astrology thing, right? Is, you know, day of the week is a little like your astrological symbol kind of thing. And maybe it matters, maybe it doesn't. We'll see. Of course, I made these numbers up, so we won't really see. Okay, the table below shows the results of a study that was recently done. Conduct the appropriate test and provide your interpretations. Okay, so here what we're doing is we want to find out whether smartphone type and day of the week born are independent. Because that's what it means for there to be a relationship. If there is a relationship, they're dependent. If there's no relationship, they're independent. So in particular, the hypothesis test we're going to use has a name, and it's called the test for independence. Sometimes you call it the chi-squared. So by the way, on your discussion post assignment, you're going to have to identify, you know, what your null and alternative hypotheses are. Some of you are going to have independence, some of you are going to have homogeneity, some of you are going to have goodness of fit. But you have to be able to write what H0 and H1 are. Okay, so H0 and H1 are actually quite easy once you've identified the test to use. H0 is smartphone type, and day of the week a person was born are independent. And H1 is really easy once you know H0. Any guess?
Not independent.
You could do not independent, but there's actually a word for not independent, which you probably know. Smartphone type and day of the week. A person was born are dependent. Right? You've heard that word before, right?
Oh, yeah.
Yeah. So that's the easy way. You could write not independent, but dependent is a lot easier, less writing. Okay, this is a test for independence. And by the way, it's always in this order. H1 always has the word dependent. H0 always has the word independent. Okay, so keep that in mind. Don't get them switched. Okay, it's not always smartphone type and day of the week, but it's something like this. Any questions so far? Okay, so now that we got that, now I'm going to go and use our calculator and pop in our data. Here we don't need to do observed and expected. We have a table. Okay, so what I'm going to do now is I'm going to go to my calculator, which is, just a minute, coming up in a second. There's the calculator. I'm going to go back to matrix, second matrix. I'm going to go back to edit. I'm going to enter. And for this one, there were 3 rows and there were 7 columns. Any questions on that? And we just type in the table. We had 75 and then 72 and then 68, 77, 70, 86, 80, and then we had 120, 111, 131, 125, 118, 124, 101, 45, 52, 44, 50, 57, 46, and 52. Just want to let you know this is a huge deal. Any of you guys know the main applications of testing for independent and dependent, and then the next step, which is beyond this class, to find out if they're independent, how are they dependent? Then it's a modern application, as in modern in the last 10 or 15 years. You don't know the main, it's huge. Okay, artificial intelligence. So things like when you go and use a browser, it knows you. Have you noticed that? So it knows what advertisement to send at you. If you start typing a little bit, it knows what you're probably going to type next. And a lot of people feel it's creepy. For me, it's not creepy, it's statistics. So what's happening is Google is, or whatever company it is always collecting data, taking that data, doing a test for independence, finding out what's independent, what's not independent. If it's dependent, finding out, doing the next level, doing this two-key analysis and finding out how it's dependent. And then the next time you go about doing it, it's going to know what the most likely thing that you're most interested in is. And that's how all of this artificial intelligence, computer learning is being done. Everything is done that way. So it's a huge application. I don't know if I lost you on that, but you probably have at least a vague idea, right? Okay, so we're just doing the very, very beginnings of that idea. Okay. The other reason why you care about a test for independence is if they're independent, then you don't have to worry about it. So if you're doing a survey, for example, and you find out that day of the week born has nothing to do with the type of smartphone, then you don't need to stratify by day of the week born. So if everybody happened to be born on Sunday, it wouldn't matter. Do you see that? On the other hand, if it is not independent, if it's dependent, then you could have bias if you only ask people that were born on Sundays. So, and again, you can extend that for any two things and look for independence and dependent. So that's another big application, is in designing studies and finding out how to avoid bias, you're trying to see what's dependent, and if it's dependent, you should be stratified. If it's independent, you don't need to stratify. Does that make sense? Okay, so my guess is none of you would even think about stratifying by day of the week born because you would just guess it's independent. So we'll find out if it really is. So the good news is the mathematics behind the test for homogeneity and the test for independence is exactly the same. Exactly. The formulas are exactly the same. You don't have to know any of the formulas because we're using our big box that's called a calculator. But by knowing it's exactly the same, now we know how to proceed because we're going to do the same thing. What's a little confusing is the null alternative hypotheses in goodness of fit and in homogeneity. Those look similar. But the math is actually different. You have to use different tests on the calculator. The H0 and H1 for independence and for homogeneity look very different, but the calculator is exactly the same. So let's do it. I'm going to go to stat. I'm going to do exactly the same. Go to tests. I'm going to scroll up. I'm going to go to chi-squared test. Observed is A, expected is B, color is brown, I really don't care. And then you calculate. So hopefully you realize this is exactly what we just did, isn't it? Okay, the difference is in H naught and H1. They look very different. Hit enter, and there we have it. Chi-squared is 9.06 about, and the p-value is about 0.6978. So at this point, you should know what that means when a p-value is 0.6978. Okay, and by the way, I know I made up these numbers, but I always try and make them reasonable. Would you expect them to be dependent? Probably not, right?
No.
Probably not. So you would expect a number of p-value like this, right? Okay, if you did a big study and you got independence, you go, whoa. But I doubt you would ever get that for this particular example. So now we can go and very easily talk about the conclusion. So I'm going to go ahead and let's make the conclusion. And again, we had a giant p-value. So we know there is, I'm going to write insufficient evidence. I like to vary it once in a while to let you know that both will be said sometimes to support the claim. Actually, I'm going to write to conclude whether or not smartphone type and day of the week, a person was born, are independent. If you want to write dependent, that's okay too, since we got the whether or not. Any questions, Josh or Jacob, on this? Any questions? So I have a question for you. What do you think the hardest part of this is? And I know as an instructor, because I grade tests, I grade the final exam. What do you think the hardest part? Where do you think people falter?
Remembering the statistic language?
Usually that's not the problem, actually, because you get a note card. A lot of people stick it on the note card.
Okay. Deciding what H0 and H1 are?
Not quite that. That's a statistics language.
I think choosing like the right test.
Yeah, that's it right there. That's it right there. Right, this little spot right here to know to do a chi-square test for independence. Okay, so that's where people have trouble because we've now had lots and lots of tests. And on the final, you're not going to be told which test to use. In fact, I'm going to have a whole question. It's a matching question. But there's going to be like an A through Q or something. And you're going to have all the different tests and an example of each, and you're going to have to say which is which. It's going to be which test you use. And you're going to have to match and say which one you use. Because that is, to me, actually, one of the most important things to get out of this class. The details, honestly, and I could be honest even though it's depressing for me, is you're going to forget them all in a couple months. Does that sound about right? Okay. But if you don't know which test to use and you have to do you're taking a psychology class and or doing some research, nothing's going to help you. You're not going to be able to go to a book and figure it out if you didn't learn it the first time. Do you see that? If you don't remember whether, H0 had the word independent or H1 had the word independent, that you can go look up quickly. Do you see that? But if you're doing a study and all you've got is a table and you don't remember what test to use, you don't understand it, you're going to have to retake the whole class. Do you see that? You're not going to be able to go online and say, what test should I do for this particular paragraph? because you're not going to find it. Does that make sense?
Mhm.
Okay. Once you know what test to use, you can quickly go online, get an example, and remember what to do. So knowing what test to do is huge, because that's a big, what I'm hoping, take out of this class kind of thing.
So for this specific question, when you're testing for independence,
Mhm.
is the indicator the first 4 words? Is there a relationship?
It could be worded differently. The indicator is you have 2 different survey questions, and they're both qualitative. Do you see that? And you have 1 population. Do you see that?
Yeah.
So we're asking, the 2 survey questions are, what day of the week you were born in, and what kind of phone do you have? Do you see that?
Mm-hmm.
They're both qualitative, right? Nothing more qualitative than Friday. That's not a number. It's not yes, no. And Android is also not a number and not yes, no. Does that make sense?
Mm-hmm.
Okay. And test for homogeneity is really the same. I told you it's mathematically the same, but it's the way you think about it. So with the men versus women, you're thinking of having 2 populations and comparing the 2. Here we have 2 survey questions and want to compare the answers to the survey questions. And goodness of fit, that's a whole different thing, because that's seeing if a distribution fits another distribution, a known one.
That makes sense. Thank you.
So let me summarize, because we're pretty close to the time I like to end. I go a little more than an hour. By the way, I used to do 2 webinars that were a little less than an hour, and I found that 1 webinar a week, students like that a little better than having to show up twice. So I go longer than an hour, but that's because there's only 1 now. So just a note, in terms of what to do when, let me write that out. I think it's good. It's important enough to write out. So goodness of fit. We have 1 known, one unknown trait of a population. And we are comparing its distribution to a known distribution. And that could be a known population's distribution. Okay, then there is homogeneity. And that is, we have 2 populations. And do not know about either distribution and want to compare. And then we have independence. And that is, we have 1 population with 2 traits. And we want to see if they are independent. And notice it's an English language, so there's lots of words for independence, right? No relationship is another word, but I want to see the word independent and dependent for your H0 and H1. So I'm not going to, we're running out of time, so I don't want to do a full example. What I want to do is I want to start. So I want to see if you can tell me what test to use. So I'm going to get rid of this. Can I erase?
Mm-hmm.
So speak now or it will be erased. Gone. Okay, so now let's look at a couple more. So let me pop it in. Okay. So 70% of all Steller's jays nests in pine trees. By the way, a lot of people think Steller jays are not what they know they are. Jacob, you probably know what a Steller's jay is. Do you know what a Steller jay is?
Oh my god.
Actually, Josh, if you've lived in Mammoth too, that's similar.
I know what a stellar jay is.
You do know?
I just am thinking of something different.
Yeah, those are the birds that we got everywhere in Tahoe. They're the ones that some people call blue jays, but they're not. They're Steller's jays. Okay, so we know that 70% all nest in pine trees, 20% nest in aspen trees, and the rest nest in other places, like my roof. Okay, a biologist has observed 250 Steller's jays nests that were given a special strength gene and then tagged to see if the distribution is different for Steller's jays with that gene. 201 of them, of these tags, jays, nested in pine trees, 39 nested in aspen trees, and the rest nested in other places. What is the hypothesis test? So I'm not going to do the whole thing. I just want to start it out. Let's see if you can tell me what test to use for this example. So what test is the appropriate test to use for this particular example? Okay, and I'm going to give you the disclaimer I always give you. I made up all these numbers. I'm not a biologist, but I do see Steller jays all the time. Definitely every day. Lots and lots of them. So what is it?
Is it test for homogeneity because your test? Oh no, that's two populations. Never mind.
Would it be independent?
Okay, it's the one I'm not hearing.
Oh, goodness fit.
It's goodness of fit. Because we have a known distribution, 70%, 20%, and 10%, right?
Mm-hmm.
Yeah.
And we want to compare an unknown distribution to a known distribution. Does that make sense?
Yeah.
So notice, and I'm just going to, like I said, I'm going to start it out, but not going to do the whole thing, because I think once you know H0, H1 in the table, the rest is kind of busy work. Do you agree? It's important, but I think you guys can figure that out. So let's try to H0. H0. The distribution. Remember, the word distribution has to be there. Distribution of nesting places for the, I'm going to call them GMO jays, is the same as for the normal population of jays. And H1, once you know H0, H1 is really easy. The distribution of nesting places for the GMO jays is not the same as for the normal population of jays. Any questions on that?
No.
Okay, now I got to draw, now I got to get the table. And again, we're doing a goodness of fit, so we're going to have observed, and we're going to have expected. Observed is going to be really easy, I promise. We have pine, aspen, and rest. And the observed are going to be, let's see, we got 201. And then we had 39. And the rest are in other places. Well, there were 250 to start with. 201 plus 39 is 240, so there's 10 left. Okay, the expected are going to be, well, you're going to take 70% of 250, because that's what we'd expect if they're like non-GMO, right? Let's call them organic J's. Okay, so 70% of 250 is what? So that's 25, 100, 175, 175.
Yeah.
If I did it right in my head. And then we had 20%. So 20% is 50. And the rest should be 25. Any questions on this? I just want to make a note, because this goes for all three of these tests, is how do you know if the sample size is big enough? Because we've seen that question before. And the answer on this one is every expected has to be bigger than 5. So here we had 175, 50, and 25, all bigger than 5, then you can use this. If you have an expected 5 or less on any of the counts, then it's not okay. Any questions on that? Okay. And then I'm not going to do the rest because you guys know how to do that, hopefully. Calculated work and a little bit of writing. Does this help to see that?
Yeah.
And my guess is that you believe me that the hardest part is trying to figure out what test to do, how to even start.
Yeah.
Once you know that this goodness fit, this isn't too bad. You just got to remember, don't put 0.7 or 70 in this first expected. It's 70% of the sample size. So goodness of fit is to test uniform distribution, normal distribution, and known distribution. This is a known distribution. Any questions? Like I said, I thought it would be a good idea to do one. Let me do another where I'm not going to actually do anything other than talk, because I want to make this really fast. Okay, so men and women statistics students were asked how much they agreed with moving from a calculator-based statistics class to a computer-based statistics class. Okay, which I've been thinking about, but I can't figure out how to do it. The results are shown below. Conduct the appropriate test and provide your interpretations. And we got the men and their results and the women and their results. Very typical survey. I'm sure you've all seen surveys like this, right? Where you have strongly agree, disagree, etc. Just a trivia question. Do you know what you call that type of survey?
Ordinal survey?
It's a 5-point Likert scale. 5-point because there's 5 choices. And I have no idea why they call it Likert. It's probably the person who they named it after. So if it didn't have the neutral, it's called a 4-point Likert scale. Okay, so the question I have for you is what test? Let's see if you can put in the chat box or say it, what test you think this is. Both of you, Jacob and Josh.
Homogeneity because 2 populations.
Okay, Jacob, do you agree?
Yeah.
Yeah, good, good. So you're onto something. This is homogeneity. We got 2 populations. We're comparing, again, 2 populations, qualitative answers. If it's quantitative, it's chapter 10, right? Does that make sense?
Mm-hmm.
If the survey question is quantitative and it's 2 populations, that's chapter 10. Chapter 11 is for the qualitative. Any questions on that? Okay, I want to give you the secret word. And the secret word is qualitative, because this chapter 11 is all about qualitative studies and how to handle statistics with qualitative studies. And as always, I'll be happy to answer any questions that you might have.
I just have one question. So I actually have a second calculator.
Uh-huh.
I just don't normally use it because I don't know how to use everything about it, but it's the TI Inspire CAS.
Okay, which I don't know as well, but it's almost certainly going to have the test for homogeneity, but you might need to download something. Let me show you something that might help you, because I think if I remember, I posted on the Canvas thing, but posting on it and you knowing to look is not the same thing, right?
It's just early in the week. I would have checked it.
Just a minute. So I got to reshare. Just a minute. Share. I don't know if that worked. Can you see that?
I can only see a sliver of it.
Okay, yeah, something looked weird. Let me stop share and reshare. I think I had too big. I think it was too big. Let's resume. How about now?
Yep.
Okay, so if you go to modules, and I think I put it here, otherwise I'll tell you. Is this where I put it? No, this isn't where I put it. Okay, so you go to, I think it maybe, let's try syllabus. I popped it in somewhere. I just got to remember where I put it. I can put it in another place too. It's not here. Calculator, calculator, calculator. Where did I put it? Sorry about this.
That's okay. I can probably find a program.
Yeah, no, but there's a really nice one. It's a YouTube video on how to make it happen, to program yourself, and it just shows you which buttons to hit to program it. Let me check one more try. Sorry about this.
That's okay.
Got to remember where I put it. Review applets, applet webinar. Try that. No. Of course, you could do it online easily, but for the final exam. For the final exam, you're going to have to do it. There is an emulator you can stick on your smartphone, actually. Hopefully you know about that. Unfortunately, I can't let you have your smartphone on the final exam because it does too many things.
Yeah.
Sorry about that. Let me do one more thing, and then I'll get you the link, because I know I had it on a syllabus. Let me go to my other class. I think I had it on that one. Just a second. There it is. Why don't I just put it on this?
Yeah, 83 or 84 calculated to the chi-squared business and fit test. But not all.
Okay, so just a minute. Okay, so it's under the statistics calculators now. And if you click that link, this gives you step by step all the buttons you have to hit.
Okay, perfect. Thank you.
And it's a 9-minute video, so you just sit there with your calculator and you hit the buttons that this woman is doing. And if you hit every button she tells you to do, then you can do it. And then it will be in your programs. So it won't be in the test. It won't be under stats. It won't be under stats and tests. It'll be under where is it? Programs, I believe. Where's programs?
Yeah, I'm familiar with it.
Hmm?
Yeah, I know where it's at. But
Yeah, it'll be under programs. And then you don't even have to do degrees of freedom. It's actually a little easier to use than the one that's built in. Yeah, PRGM. It'll be under that.
Cool. Perfect.
And
Thank
it'll
you.
be called GF is what I called it, at least.
Yeah, I'll call it that. All right. Have a good night.
Okay, you too. Have a great night.
Thank you.
And for all of you watching this as a YouTube video, make sure you get the secret word and post any questions you have on the Q&A forum or the project discussion forum.